Hey, everybody. So today we're looking at 4.5 part 1, dealing with equations of parallel and perpendicular lines. On your piece of graph paper, go ahead and get this first, the definition of parallel lines, and then get this drawing of, what two parallel lines look like. You can go ahead and put that on your first graph. All right, so go ahead and take a second, pause the video, get this, and then we'll move on. Okay, so this is saying that parallel lines, here's what they are. It says if two different non-vertical lines in the same plane have the same slope, then they are parallel lines. Okay, so that's kind of what it's all about. Two lines that have the same slope. All right, which by the way, non-vertical just means they can't be completely, vertical up and down when it comes to these graphs. All right, but we won't be seeing that. Okay, so yeah, that's what it's all about. Same slopes on this. All right, so with that in mind, let's go ahead and try our first example. Okay, so on your next graph, this one here, go ahead and copy the directions for this example. All right, get this first line on your graph. Make sure you get these 2 points exactly where I have mine, and then we'll try this one out. Okay, so it's asking us to graph a line parallel to this line with a y-intercept of 5, then write its equation. Okay, so first things first, the way we're going to be graphing these lines are using what's called slope-intercept form. All right, and this is something you saw in algebra, but if you guys remember, slope-intercept form is y equals mx plus b. All right, this is the form of the equation, and so add this to your problem here. Okay, but the first thing to remember is that m is the slope of the line. All right, b is the y-intercept. All right, so when they say write its equation, this is what they mean. They want us to plug in the slope of the line and the y-intercept, and we'll have our equation of a line parallel to this line. Okay, so now the question is, how do we find these two things? Okay, well, first things first, they told us that the line they want from us has a y-intercept of 5. They're giving us its y-intercept. All right, so if we were to start writing this equation, y equals, I'm going to leave a spot for our slope. We'll get to that in a second. Okay, but our y-intercept, again, it's a positive 5. So let's go ahead and plug it in. So 5 on this one. Okay, but I guess the next question is what's the slope of this line? Okay, well, we know that our line is parallel to this line. Okay, and the big thing to remember about parallel lines is they have the same slope. If we can find the slope of this line, we will know that ours has the same slope. All right, so let me remind you on how to find the slope of a line. Okay, if you guys remember slope, this is maybe something else you might want to add. I'm going to put it over here. Slope, a little shortcut to remembering how to find slope is it's rise over run. All right, what that means, rise is how far up and down do we need to go from one point to the other. Run is how far left and right do we need to go. Okay, and a reminder on this, when we go up, that's in the positive direction. When we go down, that's in the negative direction. Left and right, when we go left, that's negative. When we go right, that's positive. Okay. All right. So rise over run. Let's when you guys go to check 2 points, I always start on the one that's closest to the left. Okay, but you can really start at either point and go to the other, and you'll get the same slope. All right, but I'm going to start at this point, and I'm going to first figure out what my quote unquote rise is. From here, it looks like we're going up 1, 2 units. Okay, so that's in the positive direction. My rise is a positive 2. Okay, my run from here is to the right 1, 2, 3 units. Okay, so I'm going to the right, which again is in the positive direction 3. Okay, so there's the slope of this line. It's a 2 over 3. All right, so I'm trying to think. I guess we'll write it over here. The slope of our line is 2 over 3, or I guess the slope of this line is a 2 over 3, which means the slope of our line is also a 2 over 3. Okay, so I actually started with finding the equation of the line first because now we can use this equation to graph our parallel line. Okay, it's this simple. the first thing we need to get on our graph is the y-intercept. All right, the y-intercept of our line is at positive 5. All right, so that literally means our line is going to cross the y-axis, this thing right here, at positive 5. Go ahead and put a point. Okay, from this point, we're going to use our slope to get our next point. Our slope is a 2 over 3, right? Rise of 2, run of 3. So from here, I'm going to go up 2, to the right 3, and get my other point. Okay. Last thing is just connecting those dots, and we have our parallel lines. So just one thing, when you connect the dots, go all the way across the graph. Make sure you have an arrow pointing in both directions. All right, but yeah, you guys can see this line is perfectly parallel to this one going through the y-axis at 5. Okay, and that's kind of the process. We're going to do another one of these together, and then I'll have you try one. So yeah, let's go ahead and do it. Okay, so on your next graph, go ahead and on this problem, our directions, we're still talking about parallel lines, so you probably don't need these directions, but definitely get what the new y-intercept of this line is. Okay, so for the directions, do this. Write the word parallel and y-intercept of negative 2. Okay, and then go ahead and draw this line on your graph. Get your points exactly where mine are, and then we will, find the equation and then graph our parallel line. Okay, so yeah, again, the form of my equation is y equals mx plus b. All right, let's start with b. We know it. They're telling us the y-intercept of our line is negative 2. So when I go to write this thing out, y equals, I'm going to leave a spot for my slope. Okay, but my y-intercept is a negative 2. We're not going to put plus negative 2. We're just going to put minus 2. Okay, so now again, the question is what is the slope of this line? Well, it's the same of the slope of this line. All right, so let's see what it is. I'm going to start on this leftmost point. Okay, it looks like we're going down 1, 2, 3, 4 units. Okay, so we're going down 4, which means our rise is a negative 4. And then our run, we're going to the right 2 units, positive 2. Okay, so I'm going to write it over here again, but the slope of our line, or sorry, the slope of this line is a negative 4 over 2. Okay, and that's fine. We can leave it, just so you know, normally slopes are in a fraction that's as reduced as possible. I can reduce a negative 4 over 2 to a negative 2 over 1. These are equivalent. They're the same thing. They're going to give us the same slope. So I think I'm going to use this reduced form of it and write up my slope as a negative 2 over 1. All right, which, by the way, we can write negative 2 over 1 just as negative 2, but we want our slope to be a fraction because we want a rise and we want a run. So I like that it's a fraction here. Okay, so yeah, there's the equation of our line. From here, we're just going to graph it. Okay, just like the last problem, the first thing we're going to put on our graph is our y-intercept. Okay, this thing crosses the y-axis at negative 2, right there. Okay, from there, we're going to use our slope to find our next point. It's a negative 2 over 1. One thing to know, this negative needs to either be applied to the top number or the bottom number. Okay, this is either a negative 2 over 1 or a positive 2 over negative 1. Okay, it needs to be applied to one another. By default, we normally apply the number to the top. Okay, so I'm going to think of this thing as a negative 2 over positive 1. All right, so from here, negative 2 means I'm going to go down 2 and then to the right 1, and there's where my other point's going to land. Okay, and when you connect your dots, you should get a nice parallel line. And yeah, that's looking good. Okay, so yeah, that's the process with finding parallel lines, writing their equations. So I'm going to have you guys try one a lot like this. All right, so on your next graph, go ahead and again, get the fact that the lines are parallel and that we have a y-intercept of positive 2. Okay, start by writing the equation of the line. You know what I mean? The y equals mx plus b. All right, so, figure out what your y-intercept is, and then figure out what your slope is and plug it into your new equation, and then you can go about graphing it. Okay, so give it a try. Okay, so what I like to do is plug in my y-intercept because they're giving it to us in the direction. So y equals mx, and then my y-intercept is a positive 2. Okay, what's the slope of my line? Well, it's parallel to this one, so it has the same slope, right? So let's figure out what the slope of this line is. Okay, from this point, it looks like we're going down 1, 2, 3, 4 units. So my rise is a -4. To the right 1. So my run is a positive 1. Okay, so there's my slope, a -4 over positive 1. Okay, cool. So there's my equation. Now I can graph this thing. First thing, get your y-intercept onto your graph. Okay, that's your first point. Goes through the y-axis at positive 2. Okay, from that point, we're going to use our new slope to find our next point. A rise of -4, a run of positive 1. So I'm going to go down 1, 2, 3, 4, and then to the right 1. There's my second point. All right, and as always, these should be nice and parallel going through those two lines. Let me see if I can do that better. Okay, that's a little better. Okay, so that's parallel lines. If you guys remember from the title, this thing doesn't just deal with parallel lines, it deals with also perpendicular lines. All right, so let me show you the rule for this. Okay, on the back side of your paper, go ahead and flip it over. Go ahead and copy this definition of perpendicular lines. And on your first graph on the back side, go ahead and show me a couple perpendicular lines. Okay, try that out. Okay, so perpendicular lines, here's what they are. It says if two non-vertical lines in the same plane have slopes that are opposite reciprocals, then the lines are perpendicular. Okay, so that's the rule. Slopes, unlike parallel lines that were the same, perpendicular slopes are opposite reciprocals. Okay, what does that mean to be opposite reciprocals? Let's just do a quick example. What if I asked you to find the opposite reciprocal of 2 over 3? Okay, here's the two things we got to do. When they say opposite, they mean if it's positive, the opposite is negative, or if it's negative, the opposite is positive. So since this is a positive 2 over 3, I know the opposite reciprocal is going to be negative. Okay, so there's the first thing. Second thing, the reciprocal of a fraction is just flipping it upside down. So 2 over 3 flips upside down to 3 over 2. Okay, so these are opposite reciprocals. Get this on your paper because it's a decent example. All right, so that's all it means is to change the sign, flip the fraction. Okay, so yeah, we're going to try to graph some of these. By the way, when two lines are perpendicular, we know this already, but they cross at a 90-degree angle. We should see that happening. It should look at it like a nice, perfect right angle. Okay, so yeah, let's try it out. So on your next graph, go ahead, get these new directions, perpendicular, and that our y-intercept is -1. And we will find we'll graph the perpendicular line here. Okay, so first thing, let's get the equation just like we did before. The equation y equals mx plus b. All right, starting with my y-intercept, on this one it says it's -1. So let's go ahead and plug that in. Okay, so I'm going to leave a spot for my slope just like before. Okay, but my y-intercept is a -1, so I'm going to just plug that in for b. Here's the big thing. What is the slope of our line? Okay, on this one, first thing, I guess first of all, we know that our line is perpendicular to this line. So our slope is going to be the opposite reciprocal of the slope of this line. Okay, so first let's figure out what the slope of this line is, and then we'll do the opposite reciprocal. All right, so I'm going to start at this point right here. Okay, it looks like we need to rise 1, 2, 3 units, so +3, and then run 1, 2, 3, 4, 5 units to the right. That's in the positive direction. Okay, so the slope of this line is a 3 over 5. Okay, so the question is what is the slope of our line that is perpendicular to this? What is the opposite reciprocal of 3 over 5? Okay, well, it's positive, so we know it's going to be negative. And if we flip 3 over 5, we're going to get 5 over 3. Okay, so -5 over 3. That is the slope of our line. Okay. Now we can just go ahead and graph this thing just like we did before. So first thing, let's get our y-intercept on our graph. Okay, it's going to cross the y-axis at -1, so right there. Okay, from this point, we're going to use our slope to get the next point, -5/3. Remember, we're going to apply that negative to the top number. So I'm going to think of this as a -5 over +3. Okay, so -5, that's a rise of, going down 5. So, sorry, I'm going to go down 1, 2, 3, 4, 5. And then I'm going to run +3, 1, 2, 3. There we go. Connect the dots. You should see a line that looks like it's at a nice 90-degree angle to the other one. Okay, and yeah, these are crossing. This looks like a right angle. It looks nice and I guess 90-degree. Okay, so yeah, that's the perpendicular way. We're going to do one more of these, and then I'll have you guys try one on your own, and then that'll be that. All right, so let's try one more again. For your directions, just go ahead and say they're perpendicular. The y-intercept is a +7. All right, let's go by writing the equation. I'll go through this one maybe a little bit quicker. So here's the form of my equation, slope-intercept form. Let's go ahead and plug in our y-intercept. It's a +7. So y equals mx plus 7. Okay, but the big thing is the slope of our line. We know it's going to be the opposite reciprocal of the slope of this line. Let's first figure out this slope. Okay, it looks like I have a rise of -1, 2, 3, 4, 5, 6. I'm going down 6 units. Okay, and then I'm going to the right 1, 2 units. All right, so I have a slope of -6/2. Okay, so here's the question. What is the opposite reciprocal of -6/2? Okay, well, it's negative, so I know mine's going to be positive. Okay, and if I do the reciprocal of 6/2, I'm going to get a positive 2/6. All right, and you could write that as your slope, 2/6. That's fine. Though, like I said, normally if a fraction can be reduced, we will, and I can reduce a 2/6 to a 1/3. Okay, so I'm actually going to write this as a 1/3. Okay, so yeah, let's go ahead and graph this thing. First thing, y-intercept is at +7. So on my y-axis, there's my first point at +7. From this point, I'm going to rise 1 and run 3. So up 1 to the right 3. Okay, and connect your dots, and we should have a nice right angle. Yep, and it looks like these are perpendicular to one another. Okay, cool. So last thing, I'm going to have you guys try one a lot like this, and then that'll be that. All right, so yeah, again, perpendicular. This one has a y-intercept of -1. So just to kind of get you going, start by writing the slope-intercept form. Okay, get that y-intercept plugged in, and then find the new slope. All right, opposite reciprocal of the slope of this line. Okay, so try this one out. Pause the video and try it. Okay, so let's start by plugging in the y-intercept. It's a -1, so I'm going to leave a spot for my slope. Slope is, oh, sorry, the y-intercept is -1. All right, the slope of my line, since it's perpendicular, will be the opposite reciprocal of the slope of this line. So it looks like the slope of this line is a rise of 1 and a run of 1, 2, 3, 4. Okay, so this thing is a 1/4. That's the slope of this line. Mine's the opposite reciprocal of that, -4/1. Okay, there it is. Right, now I can graph this thing. So first thing, y-intercept crosses at -1 right there. Okay, from that point, I'm going to rise -4 and run +1. So I'm going to go down 1, 2, 3, 4 to the right 1. Boom. And there are my perpendicular lines. Okay, so yeah, that's just a nice little, I guess, review on how to graph lines and how to, know when things are perpendicular or when they're parallel. Remember, it's all about the slopes, and parallels being the same slope, perpendiculars being the opposite reciprocal slopes. All right, everybody, thank you.